have that right here. Oh my goodness.
You did take it from here last time.
I don't know. I did take it. Now it's not there. I don't know. So we're gonna take it from here. No worries. Specimen paper 5. Right. Okay. Okay. So now let's put it into our. Okay, better. And let's do this. So we are now going to look at question. Yeah, this was the same question. And now we're going to look at this one. Okay. So question 2 is basically, I would basically spend most of the time here because this is kind of lengthy. It's not difficult, it's lengthy. So it shows you an equation and it will always do that. The rest of the things you can read, obviously. Sometimes they're important. So right now I don't see they're important. So the first thing you see is that they say the graph of 1 over v on y-axis against 1 over v on x-axis. So when that comes, which means you need to make this your subject of the equation. So what I'm going to do is, what to do. If I take reciprocal, then it will be 1 upon v equals to p plus q over p and 1 upon e. Do you guys agree?
So you said reciprocal, so it will be plus 2, right?
Sorry?
You said reciprocal, so it will be p upon p plus q.
So I also have to take the reciprocal of this, right? No?
No, I'm saying like,
It will be like this. And if I take v there and bring this here, so it will be 1 upon v equals to p plus q over p times 1 upon e. No?
oh, okay.
Yeah. So you have to take reciprocal of each term then. And then what you're going to do is you're going to basically, I need 1 upon p as well on the x-axis, right? So I need to make that separate from here. And to do that, I can do p over p plus q over p. Can I do that?
Sir, I also think that I just realized the meeting isn't being recorded.
No, the meeting is being streamed. That's why it's not being recorded.
Oh, okay. So are you recording it?
Yeah, it's being recorded. It is
Okay.
it is going on. Okay, so then it will be 1 upon v equals to 1, p and p will cancel, and this will be q over p. And then when we multiply e with this, so it's going to be 1 upon v equals to 1 upon e plus q over p and e. You guys agree? So this is just take little bit of your practice, and now you can write it as q over e times 1 upon p plus 1 upon e. Can I do that? Would you guys mind? Now when you reach this state where now you can clearly see these two things, it means that this is your y-axis, which is equal to m times x. So this is your x-axis plus c. So it means the gradient will be q over e and y-intercept will be 1 upon e. Please have a look at it and let me know if you do not understand that. Okay. All right, should I go forward then? Cool. Now, so then we're gonna look at this particular part. So this is one of the most important because you need a bit of understanding of uncertainties. If you are still lagging behind in your AS, you're supposed to relearn your uncertainties. Watch some videos, all right? And if you need my help sometime to ask. So first of all, it says each value of P has an uncertainty of 10%, okay? Which basically means that P is here and we need to write 1 upon P, right? So we're going to take our calculator out and we're going to say fine, and it says you need to include uncertainty in this value as well. So 1 over 250 is 0.004, which is basically 4. Do you guys understand? Times 10 raised to minus 3. And then the next one will be 1 divided by 330. So it's going to be 0.3 into, okay, right 3, it's fine. But it's two significant figures, so we have to somehow we need to make sure it's 3.0. Anyway, so because this is like two significant figures, so that's why I'm also writing it two significant figures. Then 1 divided by 470, and that would give me somewhat like 2.1, and then 1 divided by 560, that's giving me 1.8, okay, according to significant figures. So 680, that would be somewhat like, Javeria, so late, that's not good.
Hello, sir. I was out actually.
Okay, so you could have taken the class on on your phone. Okay, now, so then you're gonna take this as 1 upon 680, which is 1.5, and then 1 over 840, that is 1.2, okay, like that. Okay, Javeria, we have finished electric field, so you got to watch the recording for that, for the first part. Now we're on to the specimen paper of 2022 for paper 5 question 2 that is left, all right? So whenever you're you're calculating something, so when you're calculating, you should remember the number of significant figures in data should be same or one more. Like you could also take it like 3 significant figures if you want to, all right? But that's completely up to you. Anyway, then you got to find the uncertainty in this. To find the uncertainty, you just need to do 10% of this. 10% of 4 would be 0.4, and uncertainty is just written as generally one significant figure. In the table sometimes we take more if the uncertainties are same, but generally we would take it as one significant figure. So it's going to be 0.3, this is going to be 0.2, this is going to be 0.2, this is going to be 0.2, this is going to be 0.1, like that. Is it clear, everyone?
So can you explain this again, please?
Yeah, so what I'm doing is I'm doing 4 times 10%. That would be 0.4, right? Although 2.1 times 10% would be 0.21, but I'm not taking that because I'm taking uncertainty in one significant figure. If there's if all of them just comes same, if all of them was 0.4, 0.4, 0.4, then I might include one more to just bring some accuracy in my graph, but otherwise it would be just one significant figure. Is it clear?
Yes, sir.
So once you've done this, then you're done with the table, and that's just for like 2 marks. That's a shame. So we're gonna learn how to plot them. Now the graph is static graph. They always give you this graph, and there are a couple of things that you should remember. First of all, let's start with plotting the first value. We have to plot 1.52, and we got to plot this. Okay, so instead of me like getting crazy of this, I'm going to take this as a screenshot. And what do I do then? How do I put it? Let me see. Is there an app that I can use right now? Yes. Copy to... No, that's not fair at all. Okay, I can't use that.
Sir, you can split screen maybe.
No, I can't split screen with this. The screenshot doesn't get split screen. So you guys can tell me, okay? You note this. So 1.52 and 4, right? So I'm going to go to 1.52, which is basically right somewhere here. And now I can see that this will be 1.55, which means 1.52 is going to be here, right? And the other value I need is 4, right? Which is, I believe, here. So I'm going to go
4 plus or minus 0.4.
that I'm going to tell you what happens. So now when you locate the point, there are a couple of things that you guys need to remember. First of all, the point should be very small. And then if you're putting a dot, you can just simply make a circle around it. But the actual point should not exceed half this box, which means if you've drawn a point like this, so I'm going to show you the actual size as well. This means this is absolutely wrong and this point is absolutely right. So let's have a look. You see? And basically you can put a point, like you could put a point and put it like this. You will get the same result.
And what about the cross?
Okay, if you put a cross, that's absolutely fine as well. But then the cross should be like this, right? Indicating that you've put like, it should not be.
Same thing.
Some people do it like this. Please don't do cross like this. Now, on the scale, it doesn't really it doesn't seem that this is like something that would impact your reading, but it does. And they take it as a blob, and blobs are not allowed. All right, is it clear?
Yes, sir.
Okay, so that would be the first tip that I wanted to give you. The other thing. Wait, let me put my screening laptop on charge. Okay. So now quickly, I'm gonna simply, plot the points. I'm gonna say this is, the next is 1.16 and 3. So 1.16 would be 1.1, this is 1.1 and 1.2, right? So it should be somewhere in the middle, right? And the other one was, what was the other point on P? 3. So that should be somewhere here, and I'm going to put a circle on it. Alright, like that. And then the next point is y-axis, please. You guys are slow. So that is 2.1, 0.87 and 2.1. Okay. So 0.8 would be this, and 87 would be 567, and 2.1. No, I think this is wrong. I should have done 1.16, right? Why did I do this? Sorry, this is not good. 1.1.
Sir, you did 1.16 and 3.
No, this one. Are you sure? This is
Yes,
1.1.
there's a point.
There's 1.1. 1.
So it's 1.26.
Yeah. So I have to do 1.1, 1.11, 1.12, right? Like that, right?
No,
So-
sir, it is 1.16.
Correct,
The
correct,
point.
No, why it is 1.16? Shouldn't it
Sir,
be?
1 by v divided by v, like power minus 1.
Oh, yes, sir.
It's 1.16, and 1 by p at 10 to the power of minus 3 is 3.
No, this is what I need, right? This is what I need.
Yes, I was saying it's 1.16.
So 1.16 should be here, no?
Yes, sir.
So
Yes, sir.
that was a mistake actually. Sorry. So it should be here. Just make sure your dot is not big enough, and that's fine. The next one is 0.87 and 2.1.
0.87 and 2.1.
0.87 and 2.1 is going to be, I think, here, because they're like 2 boxes each, right? So I'm gonna put it right here like this, and then we got
0.769 and 1.8.
0.769 and 1.8. So 0.76. So it's 69 is almost 7. So don't worry about that. And 0 point, and the next point was, I mean the point on
1.8.
1.8. Okay, so 1.8 should be, this should be 1.6, 1.7, 1.8. Okay, so you're gonna go here slowly, and you're gonna reach here, and erase the other stuff. Okay, then what you get? Next one, please.
It is 0.671 and
0.657. Okay, and 1.5.
No, 0.671. So it's you can say take it as 0.67
Yeah, I've taken it 0.67 and 1.5, right?
and 1.5. Yes.
Okay, so this would be the point. And the next one?
The next one is 0.610 and 1.2.
6.1 and 1.2. 1.2 should be 1.1, 1.2. Okay, so this comes here. So we got all the points plotted now. So
what happens to the uncertainties, like plus or minus?
For that you gotta wait. Okay, I'm telling you. So now when you plotted this, they will say include error bars. So in 1 upon b, and that's where our uncertainties is. So the first one has 0.4. Okay, so it means plus minus means that 1 upon p is horizontal. So uncertainties will also be horizontal. So plus minus 4 means that if you notice on the horizontal, every point is basically like 4 minus 3.5 is 0.5, and you divide by 10 boxes. So every point shows you 0.05. You guys agree? Do you guys agree?
Yes.
So if I want to know how many boxes will be there in just 0.4, so I'm going to divide 0.05 with it. How many boxes there will be? I think 40 divided by 5 is 8, right?
Approximately 8 boxes, I believe.
Not approximately, exactly 8. So then what we're going to do is we're going to count 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to put an error bar. So this is a plus, and then 8 on the other side.
Won't that become... Sir, but won't that become like 4.8 and then 4 point?
No, 0.05 times 8 boxes is 0.4. That's our uncertainty. Do you understand?
No, I'm saying like, oh, okay. So I was just saying that won't it become like 4.8?
It basically
Like
means...
if you scroll down once to the x-axis.
Yeah, so
you see like
4.4.
Like, you drew the error bar. It will be like 4.8 this side and 3.6.
4.4 and 3.6. That's correct. What's wrong with it? Nothing.
Oh yes, sorry. 4.4 and 3.6.
Yeah,
Yes.
so that's fine. That's what uncertainty is. All right.
Okay. So we just have to draw the line.
Yeah. And then in the next one, it is like uncertainty is 0.3. So we're going to count the number of boxes. So 0.3 divided by 0.05. How many boxes should I go? 30 divided by 5. 6, right? So what I'm going to do is I'm going to count 6 boxes now. 1, 2, 3, 4, 5, 6. And on this other side is 1, 2, 3, 4, 5, 6. So these are the boxes then. And then in this one, the next
Next one
uncertainty
is
is
0.2, which is
okay,
4.
which is 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, then 1,
The
2,
next one
3,
is
4.
also 0.2.
Yeah, 1, 2, 3, 4. Okay, very good. And then 1,
Then the other
2,
one also.
3, 4. 1, 2, 3, 4. Okay, the next one, the
2
last one.
boxes.
So 1, 2, and 1, 2. Okay, now we're done with the uncertainties as well. So now, once you've done this, you plotted them, you've done the error graphs, and then they say draw a straight line of best fit and worst fit, and you should also label them. Now, what is a best fit line? Again, I'm just telling you I should write it here, okay? I'll write it here. Best fit. Best fit basically means line close to all points and dividing points above and below. So it has nothing, it has no, particular condition that you should touch most of the points or you should cross from most of the point. That's all crap. Do not believe in it. Anyway, so now what you're going to do is you're going to try to I'm going to make it digitally. Sometimes, my line doesn't like me. So I'm going to make it somehow. So I need to be closer to all points, and then I'm gonna shift it somewhere like this. So I've got like almost 3 points in a line, and I could move it a little bit on this side, and I could move a little bit this side. All right, so if you notice, I have 4 points on a line naturally, which is not a requirement, and 1 point is above and 1 point is below. So that perfectly fits my description of best fit, and I'm gonna write.
Sir, I think some people say that you have to draw the line starting from the origin and end it to the last point.
No, that's
Can
not
we
a requirement. No,
use that as a reference?
No, that's not a requirement.
No, it's a reference. Like, for example, if you see a line as well, it starts at almost the origin and it ends at the last point. So, assuming the same reference, if we draw the line starting from the origin 0.5 to 1 and ending at 1.5 and 4, like, won't it become the line of best fit?
I don't know. You could try, but it won't become line of best fit if equal points are not above or not below. That's the only condition.
Mm-hmm.
Do you understand what I'm saying?
Yes, sir.
Okay, so keep that condition in mind. Now, so the next thing is the worst fit. Now, what exactly is the worst fit? Worst fit is it should basically start from top or bottom end of error bar, and number 2 must end bottom to top. Let me just tell you what I mean by this. So you can draw a line like let's take this line. So you can draw a line either from this side and cross it like this. So if you're choosing to draw from this end, okay, delete. I also need to, I should have delete, and I should have colored this. How do I color this? Color this red, or okay, fine. So what I've done is, you might understand that if I'm choosing this point as my start, then I have to cross the line to the other point. So you're taking it from the highest uncertainty, you have to go to the lowest uncertainty. You could also do the same thing by making sure that this line goes like this. That could also be like a similar sort of pathway, all right? But it should cross the line, which this one is not crossing. So you can't do that, all right? Anyway, in some questions you can do. Anyway, the next thing, the third thing you should always remember is that the uh, worst fit line must cross all the error bars. That's a requirement. All right.
Sir,
Yeah.
like, do we have to draw only one line, or we have to like draw from each point?
You have to draw just one single line from the top of the error bar to the bottom one, or vice versa.
Okay.
So does it have to be a dotted line, the worst one?
No, it's not a dotted line. It has to be a solid line. Is it clear?
Yes, sir.
Now, it could be the steepest line, it could be the shallowest line, it's up to you. But when you do that, you have to
We have to
basically,
label it as well.
yes, you have to label it. Labeling is very important because otherwise the examiner would not understand what you've done. All right, is it clear? All right, so from this point onwards, what we need to understand is that this whole system, they would require you to find the gradient and the uncertainty of the gradient. So how would we do that? So the main formula for this is that first you find the gradient of best
Y2
fit.
minus Y1.
Yeah,
X2 minus.
that's the same thing. But the thing is that you have to find the gradient of best fit and you have to subtract it from the gradient of worst fit. All right. This will give you basically the uncertainty in gradient. That's how you find the uncertainty in this.
Sir, but in the question they just asked, determine the gradient of the best fit only, right?
And include the uncertainty. Read the next line as well.
Okay.
And then
No, include the absolute uncertainty in
Yeah.
your answer. So
this is how you do it.
does it mean like, oh, okay.
Then in the answer section, you're going to write the gradient of best plus minus the uncertainty that you found using this. Do you guys understand that?
Yes, sir.
The other rule that you must always follow is that this should be one significant only, and this should be same decimal places as uncertainty. So this has to be kept in mind before writing the answer. I hope that's clear.
Yes, sir.
Now the other thing you guys need to do is when taking the gradient, what to do. So the thing you should always remember is that suppose we decided, okay, that you want to take the gradient from this point and this point, okay? So try to always take unique points because you don't know whether the points that they're given in the table exactly cross the line or not. So you have to take the points on the line, and then you also need to make sure that you need to draw this triangle. All right, so draw triangle. Drawing triangle basically tells the examiner that you have taken this point and this point as your gradient point. The next thing you guys need to remember is, and that is a very important one, that the distance between the two gradient points, so I'm writing here, distance between two gradient points must be greater than 50% of line. So if you're taking a gradient, a very small gradient like this, right, it would not be acceptable. Is it clear, everyone?
Yes, sir.
All right. So you can take the gradient here, and obviously you can take the other
So
gradient.
it's best to take the gradient one point close to the bottom and one
Yeah.
point close to the end.
It's not that like you can take the point you like. It's not like that. But the point should be somewhat reasonably away from each other. Like for example, if I take this point, that's fine because it's more than 50%. Basically, this is the same point as this one. I would not take that in the actual exam with the coincides, but you can take it, it's fine. All right. So when you take these 2 points, obviously, so then you got to find the gradient, and like Mokshit has said, the gradient has to found out by y2 minus y1 and x2 minus x1, or just rise over run that you guys have learned. All right, is it clear?
So you mean
Yes,
the
sir.
two triangles should be separate, like they should not coincide?
They can, but I would not do that.
Okay.
I would not leave any area for the examiner to get confused, because he has to physically check this, right?
Right.
So he should not be confused. If I were you, I would not do that, but that doesn't discredit
So,
anything.
sir,
Yeah.
the point that you chose for the worst fit on the y-axis, it is almost like coinciding with the previous one.
Yeah, it is coinciding actually, but I would not
So
take
why
that
not
point.
take it a bit below or
Yeah,
a
yeah.
bit above?
That's what I'm saying. You should, and you can. But in any rule, this is not a rule. This is just a advice. All right. So it would not give you any discredit or anything like that. So you don't have to worry about that. All right. Is it clear, you guys?
Yes, sir.
Okay, so what I'm gonna do is I'm gonna save this file, and I'm gonna, next time when we're doing this, okay, we will come back to this, and whenever we get time we will do the other parts. All right, I hope you guys learned something.